All right, so today we're going to talk about limits involving infinity. And that's two different types. The limit as x goes to positive or negative infinity, and cases where the limit as x goes to, say, 3, where the limit is infinite. So either x is going towards infinity or the limit is infinite. We're going to talk about both of those today. So when we say the limit as x approaches infinity, we mean the limit of f as x moves increasingly far to the right on the number line. For the limit as x approaches negative infinity, we move increasingly far to the left on the number line. Okay? So one in particular that you were very concerned with last year in pre-cal, you did a lot of problems on these, is horizontal asymptotes. So the line y equals b is a horizontal asymptote of the graph of the function y equals f of x if either one of these two things is true. The limit as x goes to infinity of f of x is equal to b, or the limit as x goes to negative infinity of f of x is equal to b. Now in pre-cal, the kind of functions we were looking at, the horizontal asymptote was the same on the left as it was on the right. It's not always true. Dun dun dun. Okay, and we'll look at a couple like that in just a second. And the reason that it was the same is we were looking at rational functions. For rational functions, if you have a horizontal asymptote on the left, you have exactly the same horizontal asymptote on the right. So let's look at some interesting functions. So use graphs and tables to find the limit as x goes to infinity of f of x, the limit as x goes to negative infinity of f of x, and identify all horizontal asymptotes of these graphs. So, yes?
On our homework, we didn't ask to graph it. Do you mind if we just draw a graph on notebook paper, or do you want it on graph paper?
Kind of depends on what it is. If you just need a sketch, that's one thing.
Yeah.
And it doesn't have to be, a work of art. All right. So grab your calculators. You're supposed to have them with you every single day.
Oh, wow. Oh, look at me. Check out my calculator. Yeah.
Ooh.
It's got Python on it.
Yeah, I can program stuff on here. But why would I use Python? Python's better than this.
Oh, you got one of the Python ones?
Yes.
So why?
It was $50 off the target. So
How
it
much
costs
did you pay for it?
only $100, which costs.
Okay.
Price on regular?
Yes.
All right.
It's priced as much as the regular one. So why not? Plus, I didn't know it was Python. My mom wanted.
And your mom likes snakes? What? So we're going to look at the graph of 3 plus 1 over x to see what the heck is happening there.
I gotta take my brother's face off.
I'm going to do a zoom standard. And you're like, okay, looks like it has a horizontal asymptote on both ends, right?
Yes.
Notice here it said use graphs, so I'm not expecting you, if it says that on the homework, for you to draw the whole graph. Okay? Use graphs and tables to come up with this limit. So let's go to the table. And if you scroll down, you're like, man, these are all really close to 3. And we're only at 40, and we're already at 3.0 something. By the way, you don't have to use what your table comes with automatically. Have you guys ever set the table?
Nope.
Okay.
Mine's in fraction.
So if you go to second window for table set,
Oh, that's cool.
you can say, I'm going to start at 0. And
Well, my sister-
we want to go to 100, right?
Yeah.
I mean, we want to go to infinity. So let's step by 100. So we're not taking such baby steps to get to something really big. Now if we go to the table, You're like, oh, this is getting big much faster. And you don't have to go too super far. I mean, we're only at 2,500. And are you pretty convinced that that's going to get eventually close to 3?
Yes. Well, mine's in fractions.
Yours is in fractions?
It is.
My graph looks different than yours, but my table's the same.
The graph looks different. So did you do a Zoom 6, which is a Zoom standard?
Yeah, I'm going to reset my calculator. I think it's still on.
Can you pull up your graph, please?
Sure.
What was it? 3 plus 1 over there?
Yeah, mine's like going under the x-axis like that.
Yep, we're still in fractions.
Check your
What do you mean radians?
Oh, you have. No, what's happening is no, you're fine. It doesn't because it's not sine or cosine. The radian part doesn't matter. It's just not quite as clean. Mine probably does the same thing. It just does it a lot closer to the axis.
Okay.
You have that little heartbeat thing, and what's happening is, and I don't know which operating system that yours is running on. You may want to see if you can update the operating system. The OS?
Yeah, I'll talk to her about it.
But it's drawing across what should be a vertical asymptote.
Okay.
There should be a vertical asymptote at x equals 0, but it's drawing across that. So
Is there any reason mine's in fractions?
Oh boy. Let's see if I can get to 3.0. Answers. Just change it to decimals. So right down here, yeah. You had it on auto, which is usually fine.
Oh, much better.
You're welcome.
So we're pretty convinced here that the limit as x goes to infinity of f of x is 3. Are we convinced about negative infinity? Well, haven't really looked yet, have we? But it sure looks like it's the same, doesn't it?
It gets to 3 at 20,000.
Yeah, I'm pretty convinced.
At 20,000. So
I got there.
do you believe that it ever actually gets to 3?
No, it didn't. Ask it. Right?
Yeah, what's happening is it's so close that your calculator only goes to, I think, 10 decimal places, and it's only displaying 4 or 5 here, and so it's rounding it to that.
No, I got it up to 3.
That's what he's saying. He's saying
It's not actually 3, it's rounding it to 3.
It's good enough.
So as x goes to negative infinity, f of x also goes to 3. Let's see if we can do this next one a lot faster than we did that one. So, clear this out. I really like using the second y equals to make fractions like this.
A real man knows that if you use enough parentheses, you will get it right.
A real man.
Yeah. I
Uh-huh.
love parentheses, and pre-cal I still have so many parentheses. I have to think ahead. How many I need to put up at the beginning.
You're just not as woke mathematically as I am.
How do you do that?
Check this out.
The fractions?
I love parentheses.
You do alpha y equals.
Never do that. Oh,
I taught him last year, but he never would do it.
I'm pressing alpha y equals right now.
alpha y equals 2.
Alpha y equals,
Oh wow, graph.
Hey, 2?
Look at this.
no, it's 1.
Oh,
One.
or 1.
Head alpha y 1.
All right.
Your calculator's slow.
Okay, so this one looks like it has a different horizontal asymptote as x approaches infinity than it does as x approaches negative infinity, right? Over here to the right, that looks like positive 2. Over here, it looks like it's negative 2. Let's real quickly check that on the table. Yeah, I mean, certainly looks like negative 2 there. Let's go the other way. Oops. And real quickly, it's looking like 2, isn't it? So the limit as x approaches infinity of f of x is positive 2, while the limit as x approaches negative infinity of f of x is negative 2.
I have a question.
I have an answer.
So,
The Nile River.
Close.
good answer.
Close.
But not the one I'm looking for, so I'm going to try again.
Now, maybe your question won't be the one I'm looking for either, but let's go ahead.
So, on the AP test, we have the calculators, right?
Not all the time, only half the time.
Will we have it on questions like these?
Maybe, maybe not. We're going to talk about how to figure these out without putting it into your calculator.
I'm sorry.
Okay? All right. Let's look at this last one. Sine of x over x.
Straight line.
It's a straight line. All lines are straight, Irfan. There's no such thing as an unstraight line unless you're dealing with non-Euclidean geometry.
From my perspective, it's a straight line.
Once again,
No, okay, fine. Okay. Okay, it is a bar that runs parallel and on the x-axis at 1 equals 0. No, I don't know.
that doesn't look very straight to me.
Oh wait, I'm
You're
not.
fine. It looks like a bridge.
It looks
Look
like
at
a
the-
straight line.
What did she do?
All right, so first of all, make sure that your calculator is in radian mode, not degree mode.
What's wrong
Oh.
with degrees?
Degrees suck. Radians are better.
I'm back to ratings.
Just like milk chocolate is better than dark chocolate. Don't go there with me. We've already done this one once.
Just use the fraction bar or fine.
I disagree, Lance.
You can disagree all you.
No, look at that. You got parentheses.
Oh,
in the right
nice.
place.
Nice graph there.
All right. So
He's gonna fail the test.
what happens? Well, let's look at the table. We start getting into about 1,000.
Whoa. I have mine at
Negative 4 times 10 to the negative 4th. So that's negative 0.0004. What is that really incredibly close to? 0. So the limit as x goes to infinity of f of x turns out to be 0. And for the sake of time, I'm just going to tell you it's the same on the other side.
Shocker. Is there any way to write that as you approach it or go both ways, they're the same?
Oh, as you go to negative infinity and positive infinity all in one? No.
Oh. I thought mathematicians were extremely efficient.
Yes.
Yeah, it just doesn't happen often enough to be worthwhile. Okay? All right, let's move on. So the properties of limits from our last section, the sums, differences, multiplication, all that stuff, also would apply to limits as x goes to either positive or negative infinity. So for example, on this problem, we can rewrite this as the limit as x goes to infinity of 5x over x plus sine of x over x.
1. It's 1. I know it's 1.
What's 1?
Sine of x over x.
Yes, the limit as x goes to infinity of sine of x over x is not 1.
It's x over sine of x.
No, the one that I asked you to memorize is this one. The limit as x goes to 0 of sine of x over x is 1. As x goes to infinity, think about that for just a second. Sine of x is limited. to values between -1 and +1 for the output, right? The denominator is becoming large without bound. So you're taking a relatively small set of numbers and dividing them by bazillions. What is that going to get really close to? 0. So this is going to get really close to 0. Here, 5x over x is going to get close to what? 5. Does that make sense that that would get close to 5? So that's 5 plus 0 is 5. Simplifying an expression in order to help you out is going to come up a ton, especially this semester. Okay, so you have to be able to simplify expressions like that. All right, moving on. So let's talk about vertical asymptotes and limits as x approaches a. So if the values of a function outgrow all positive bounds as x approaches a finite number a, we say that the limit as x approaches a of f of x is equal to infinity. Now, we're going to stop there before we move on. Technically speaking, the limit does not exist because the function is not going to a particular value. So when we say that the limit as x approaches a of f of x is equal to infinity, we are explaining why the limit does not exist. We will always do this. And the AP exam is consistent with that. Okay? But we're saying there is no limit because the values become large without bound. They tend towards infinity. So then the line x equals a is a vertical asymptote of a function y equals f of x if either the limit as x approaches a from the right of f of x is equal to positive or negative infinity, or the limit as x approaches a from the left of f of x is equal to plus or minus infinity. So here, we're going to find the vertical asymptotes of each function and describe the behavior to the left and right of each vertical asymptote. Again, part of this is stuff that you did in pre-cal. So you did a whole bunch of these kinds of functions. These were rational functions. How do you find the vertical asymptote for a rational function? You look at what? Nope. Okay, what causes a vertical asymptote is having a 0 in the denominator and having something that is non-zero in the numerator. So if you have a non-zero over 0, God bless you. Because, let's think about this for a second. Let's say that the numerator goes to 3 and the denominator is getting really, really small. If I take 3 and divide by something really, really small near 0, what kind of a number am I going to get? Something incredibly large. So if I have something finite that's non-zero divided by something that's very close to 0, I get something that is infinitely large. All right. So let's look at this first one. What value of x is going to make my denominator 0 but not make my numerator 0? 1. So I want x minus 1 to be equal to 0, which means that x is equal to 1. So that is my vertical asymptote. And a vertical asymptote is always an equation. If you just put 1 for your answer on that, I'm going to be like, what about it?
So the x equals 1.
Yeah, x equals 1.
In parentheses?
Why?
I don't know. I just think like you're a parentheses type of guy. You have to do parentheses a lot.
But it was never for no reason.
Okay.
All these quotes would make great merch.
You look like a parentheses kind of guy.
Or just wait till the homework.
Just wait till the homework.
All right. So now what we need to do is find what is the limit as x goes to 1 from the right of f of x. And here's where I do something, and I don't know if Mr. Hedstrom does this, but this is the way I do it. So substituting in 1 plus 2 in the numerator gives us 3. In the denominator, 1 minus 1 gives us 0. Now that's undefined, right? But
It's a limit.
as a limit, what's going on? Well, if I am using values that are larger than 1, because I'm approaching 1 from the right, so like 1.1. 1.1 minus 1 is 0.1. It's a small positive value. 1.01 minus 1 is likewise a small positive value. This is not standard at all, but this is the way I think about it. This is a positive number near 0. And I just write plus 0.
That's your answer?
Nope.
I'm just checking.
And technically, this isn't really an answer at all. This probably should go someplace else because it's not really equal to that because this doesn't exist. But if I have 3 over a positive number, a positive divided by a positive is going to give me a positive. So I've got 3 over some positive, really tiny number. What's that going to move towards? Infinity, yeah. So you really don't want to write that it's equal to this because technically that's just not true. But it is, it goes to infinity.
I don't think Mr. Hedstrom did it like that.
Mr. Hedstrom, have you ever watched Toy Story before? Oh, well, you said Mr. Hedstrom, I'm sorry. Mr. Davis.
All right, so for this one, I'm not going to put the equal to, I'm going to do a little work over here and go, okay, the numerator goes to 3, the denominator goes to 0, but now as I move towards 1 from the left, slightly smaller than 1 would be like, for example, 0.9. Just a little bit to the left of 1. So if I took 0.9 minus 1, am I going to get a negative number or a positive number? A negative. Oh, now I have a positive divided by a negative. What's that going to be? Negative. So this is going to go to negative infinity. Cool?
You really call it beyond? It's going downwards? Yeah, it's going negative.
Beyond.
That's negative. Beyond.
It goes straight to hell and doesn't stop? I don't
Yes.
know.
Have you ever had a Beyond Burger, Mr. Davis?
And beyond.
I don't like artificial meat.
It's made out of plants, though. It's not like.
Yeah, that stuff looks really weird.
It's like plants and then like part of an animal. It's kind of weird.
Ew.
What do you mean part
I don't want to.
Yeah,
I don't
this-
wanna try
It's
that.
not supposed to have.
I thought the
Like,
Beyond
it
didn't.
has like hemoglobin or something.
It's monoglobin. Not hemoglobin, it's monoglobin.
All right. So for this one, we want to make the denominator equal to 0, but the numerator not. So x plus 3 quantity squared equals 0. Now taking the square root, that means then that x plus 3's got to be 0, which means x is negative 3. Does that make the numerator 0?
Yes.
No.
Oh, not the numerator. It makes the numerator 57.
Yeah. So our vertical asymptote
It's grown.
is x equals negative 3. Now we want to see what happens to the left and what happens to the right.
So you did negative 3 because negative 3 plus 3 would be 0.
Correct.
Okay.
Or subtract 3 from both sides and solve. Either way. So the limit as x approaches negative 3 from the right of f of x. Well, again, I don't want to write this as equal because I'm going to have 0 in the denominator and it can't be equal to that. But let's see. Negative 3 minus 4, as you guys said a second ago, is negative 7. If I'm slightly larger than negative 3, this is where it starts to get a little bit hard for a lot of people. Slightly larger than negative 3 would be like what?
Negative 2.99.
Yeah, negative 2.99 plus 3.
Oh, it's like 0.01.
So 0.01, so a small positive number, right?
Yeah.
So I've got a small positive number near 0, and I'm squaring that. So it's an even smaller positive number near 0, right? So I've got a negative over a positive. This is going to be exactly as Paul said. That's going to be a negative infinity. He shoots, he scores. On the other hand, what about the limit as x goes to negative 3 from the left? And you would be wrong. So now I've still got something that's near 0. If I take a value to the left of negative 3, that would be, for example, all right, negative 3.01 plus 3.
No. Negative.
Right, negative 0.301. So this is going to be a negative number near 0, but we're going to square it.
So then it becomes.
Infinity again.
So it's positive, so this is negative infinity again. So if you were graphing this at negative 3, there's a vertical asymptote, and both ends of the graph are going downwards.
It's a volcano graph.
An upside down volcano?
It's a nuclear cooling tower that imploded.
Nuclear power
I
plant.
love
Upside down.
nuclear.
It's in the upside down world.
It's a hole.
It's an upside down nuclear
It's a
cooling
whole
tower.
tower.
It's a hole.
Tower.
All right. So I promised you, let me stop this recording.